Alright, hey, today we are talking about Natural Wonders Chapter 11, which is all about weathering and erosion. And weathering is just simply the breaking down of material, so taking a big rock and making it into smaller rocks. And erosion is transportation of sediment, and we're going to see both in this chapter. When we talk about weathering, there's two different types of weathering. The first type is mechanical weathering, which is the physical breaking down of a material. So it is breaking apart physically. In terms of chemistry, it's staying the exact same, it's just becoming smaller pieces. The second type of weathering is chemical weathering. And chemical weathering is when the chemistry of the rock is being changed and it's being worn away because of its chemistry, the elements, and really a reaction with water. So as we go through the chapter, make sure you're marking which features are examples of mechanical weathering, which ones are examples of chemical weathering, and which ones are examples of erosion. Starting with the first feature, we have ice wedging. And this is a process that's really important here in Michigan. And what happens is that during the day, water gets into cracks and rocks. And at nighttime, potentially like certain times of the year, certain locations on the planet, where there's daytime higher temperatures above freezing and nighttime cooler temperatures, the water in those cracks will freeze, and we all know that when water freezes, it expands. And when that water expands, turning into ice, it makes the crack even larger. And again, certain places on Earth or certain times of the year, like right here in Michigan, every spring, every fall, we have this day and night cycle of freezing and thawing, freezing and thawing. And this just really tears up the roads here in Michigan. If you think about potholes, this is exactly how potholes form. During the day, water gets into cracks in the road. At nighttime, those cracks expand when water turns to ice. And that process happening every day and night for a period of time. And then on top of that, cars traveling, tires kicking out these chunks of loose road, it makes huge potholes. In Natural Wonders, you're going to see rock outcrops that are surrounded by these massive piles of loose rock. All of that material actually came from the cliff, from the outcrop itself, and it was knocked off because of ice wedging. The next feature is exfoliation. And exfoliation is again a type of mechanical weathering, just like ice wedging was. This time it's dealing with rock layers that were under a lot of weight for a long period of time. Maybe like a glacier along with overlying rock layers and sediment. This causes rock layers deeper in the earth to be compressed. Eventually, when the glaciers melt, the sediment is removed, the stress, the pressure on that compressed rock layer is removed, and the rock starts to expand. And when it expands, it also forms these kind of parallel cracks that you see in our example of Half Dome. And these exfoliation domes and just exfoliation form when rocks expand to the point where they almost separate, and in the video clip you can see them popping off and then collapsing, kicking out a bunch of dust, which I'm pretty sure this is the only video clip ever recorded of exfoliation like this. So it's really cool. The next feature is chemical weathering, which obviously is an example of chemical weathering. What you're going to see in the different clips are either limestone blocks or marble statues that have been eroded chemically over time. All rainwater is slightly acidic, and when that slightly acidic rainwater washes over top of a limestone rock, it's going to cause some chemical weathering. If you remember back to our mineral identification labs, we had calcite. And calcite would react with hydrochloric acid, it would fizz and bubble, and it would release carbon dioxide. That same type of process happens with limestone blocks and slightly acidic rainwater. Not to the same extent, we don't get the crazy bubbles that would be kind of terrifying, but the same type of chemical process is taking place that is removing and dissolving the limestone away. The next feature we have are caves, and caves again form through chemical weathering. It all starts with limestone rock layers underground. Because groundwater flows through these limestone rock layers, and groundwater, just like rainwater, is slightly acidic, over time the groundwater can erode away, dissolve away that limestone rock layer, just producing an empty space. And that empty space underground is what we call a cave. The next feature is our first example of erosion, and it's just called the Dust Bowl. These dust storms occurred sometime around the Depression era. And during that time, during the Depression, people were really struggling for food. So farming was really, really important for getting food for all of these people that are struggling with jobs and the economy, and they just need to find food to eat. But farming can be done in a way that's kind of hurtful to the soil. Over farming dries out the soil, removes all of the nutrients, and leaves it pretty much dusty and salty. This over farming, paired with just a natural drought taking place during that time, produced this layer of dust that covered all of these huge farm fields. So it won't take a very big windstorm to kick up all that dust into pretty much just a scary dust cloud. And so these dust bowls formed as a form of erosion. And they weren't necessarily too dangerous to, healthy individuals, but older people and younger people, babies, if they breathe in too much of this dust, it would scratch up their lungs, they would get, infections, and potentially could die because of these dust bowls. The next feature are sinkholes. And sinkholes, they are very closely related to caves and limestone. Sinkholes form when caves that form in limestone rock layers, when these caves collapse. And if you think about it, the surface of Earth is supported by the rock layers underneath it. If we remove those rock layers, we no longer support the surface of Earth, and it can just fall into that empty space. And that's exactly what sinkholes are. It's when the surface of Earth collapses into a cave. A large land area full of sinkholes, like you see in the picture, is called karst topography. And lastly, we have meanders. Meanders, we're talking about flowing water. We're talking about rivers. And rivers are by far the most erosive force on the planet. So again, we're looking at examples of erosion. The meanders that you have to kind of point out here are just the bends. When you look at some of these pictures, you can see how curvy and bendy these rivers really are. And every single one of those bends is called a meander. It's also important to kind of point out that on the inside of all of these turns, on every single meander, you're going to see deposition of sediment. This area where the water slows down on the inside of a turn is called a point bar. And again, that slow water causes deposition, ends up being sandy gravel material deposited there. If the slowest moving water is on the inside of the turn, it means the fastest moving water is on the outside of the turn. And this causes erosion, the removal of sediment. And we call the outside of the turn, the outside of the meander, we call it a cut bank, where you're cutting away, eroding away at that bank of the river. Something really interesting that can take place with rivers is when two cut banks erode a shortcut in the river. The very last picture you're going to see, the top-down view of this meandering river, in some areas these cut banks are getting very close together. It'll only be a matter of time when the erosion makes a shortcut for the river. After that shortcut is produced, of course the river is going to take the shortcut. It wants to get to sea level as fast as possible. It's not going to take the detour. And that means we have a stagnant, still body of water that's in the shape of a horseshoe. We call these horseshoe-shaped lakes, we call them oxbow lakes. Eventually there's deposition that cuts them off completely from the river, and it really is just a horseshoe-shaped lake. No flowing water whatsoever. Alright, that's it for chapter 11. Please make sure you finish up your focus questions, and you're asking me questions if anything doesn't make sense. Alright, good luck.